Good morning, good afternoon, good evening, as per your location. Today we are going to have webinar on climate smart agriculture water management, best practices, policy framework, and way forward. We have a very learned speakers and panelists. Dr. Yella Reddy, he is Dean of Agriculture University and Vice President Honorary of ICID. Then we have other panelists also. Dr. Micro-irrigation, he is the Vice President of ICID. Then Dr. K. Palani Swami, he is from former IMI staff, and then he is emeritus scientist of IMI. And Mr. Anshuman from TERI, the Energy and Resource Institute in Delhi. So we have our president also, Dr. Raghav with us. I'll request him to give his opening remarks before we start the webinar.
Thank you, Mr. Harish. This is actually a webinar related to the ICID vision for a water secure world free of poverty and hunger. The issue of today is the climate and the climate impact on agriculture and agricultural water management. Of course, our food production is very much climate dependent, depends on the precipitation, temperature, radiation, and carbon dioxide. And all those actually parameters, they affect our yield and they are changing with time. And according to the change in the climate, we need to have a smart solutions. How can we cope with the climate? How can we adapt and how can we mitigate? And the talks of today will actually highlight those issues and how can we actually adapt ourselves to changing climate by really going to use new approaches, and those approaches will be highlighted by Vice President Yella Reddy, who is actually going to address this webinar as a keynote speaker. The floor is yours, Vice President Honorary Yella Reddy. Thank you.
Dr. Reddy, just wait.
Yeah.
I'll introduce all the panelists first, and the speaker yourself and the other panelists, and then we'll start.
Sure.
So, Dr. K. Yella Reddy is Dean, Faculty of Agriculture, Engineering and Technology of ANGR Agriculture University, Andhra Pradesh, India. He has more than 35 years of experience in teaching, research, project management, and administration. He obtained BTech Agriculture Engineering from Akola Engineering College, and MTech and PhD degrees from IIT Kharagpur and PG Diploma from University of Arizona, USA. He has developed solar-powered micro-irrigation system in 2002 for Andhra Pradesh. He has implemented a number of projects, which includes Andhra Pradesh micro-irrigation project. And as a director of Valamtari, he has contributed to the growth of institute as one of the best in India. He has organized over 25 national and international conferences and workshops and published over 120 scientific papers. He received ICID WhatsApp Technology Award in 2008. He was elected as the Vice President in 2017, and now he is a Vice President Honorary. Dr. Micro-irrigation, he is Vice President of ICID and he is Secretary General of Eternal National Committee of ICID. He is a technical officer of the Southern Italy Hydrographic District Authority, Ministry of Environment, where he works since 2006. He graduated from the Faculty of Agriculture Engineering of Basilicata, where he also gained his international PhD on crop system forestry and environmental sciences. His professional experience brought him to visit more than 40 countries. During his scientific activity, more than 25 years now, he has produced several papers for peer-reviewed journals. He is currently the Senior Vice President of ICID as well as Secretary General of Italian National Committee. Dr. K. Palani Swami is an international agriculture and water expert with a specialization in agriculture economics and water policy and climate change. He worked in several countries for about 12 years as a visiting professor and project scientist. He was also a consultant to World Bank, JICA, IFAD, and ADB projects implemented in different countries. He was the director of Water Technology Center and CARDS, Tamil Nadu Agriculture University, and principal researcher at IMI from 2008 to 2014. He has received several awards and fellowship at national and international level for his water and agriculture related works. Currently serving as emeritus scientist of IMI and consultant to ADB and Tamil Nadu Agriculture University. Mr. Anshuman is Associate Director, Water Resources Division of TERI, that is the Energy and Resource Institute. He has been working in the field of water sector since last 24 years. His key qualifications include MTech in Energy and Environment Management from Indian Institute of Technology, New Delhi. His expertise in water sector lies in areas related to integrated water resource management, water use efficiency, water quality, and quality assessments. He has been member of several advisory committees of Government of India and Bureau of Indian Standard and other agencies. He has executed several related projects, presented several papers at national and international fora, and has several relevant national and international publications. And just that is for information of the all the participants that we'll be sharing the recording of this webinar in a day or two on our website. So if anybody is missing, then they can see that recording. You can send your questions through question answer section or chat. We'll answer those questions, try to answer those questions at the end of the presentation. And if time permits, we may give speaking rights to few of the participants, and you can raise your hand. So we'll see if time permits, then we'll allow you to speak, and we'll unmute you and we'll allow you to speak. Then now I request Dr. Ella Reddy to start his presentation.
Shall I?
Yeah, please share your presentation, please.
Is it visible?
Yeah, that's good.
Thank you. I am really delighted to see all the panelists there. Dr. Marcos, Dr. Palani Swami, Anshuman, and our own President ICID joining from UK and headquarters. All the participants. Very good afternoon from India. In fact, this webinar series ICID does regularly. So today, climate smart agricultural water management, best practices, policy framework, and way forward. So why we need to do it? Because today we are experiencing effect of climate change everywhere. We are seeing that how that we can incorporate to certain extent in our policies, how we can adapt at a ground level some initiatives taken at different levels. Keeping that in point of view, I just want to make a brief presentation because we have very eminent panelists. I want to give enough time for them also. So my experiences, different places, wherever I worked. Okay, I am trying to share a little bit of it related to the topic. First is water and climate change. Okay, just a brief intro I give. Relevance of water policy. We have a national water policy at Indian level, and like many countries have their own policies. And we need to link to new approaches like water footprint and virtual water approaches in water management and my experiences, and what is the ICID also doing, how this is getting connected, and the future ahead. Most importantly, it is the UN Sustainable Developmental Goals across the globe. All the countries today focused in achieving the development and eliminating the poverty, all that, having some set agenda. And all the countries across the globe, they are partners in that. By 2030, we are supposed to achieve all the goals. And when we look into the Sustainable Developmental Goals, water is very key important component to achieve these goals. Without water, there is no life. So that is the importance. And if you organize the goals in a more different way, the central one, okay, that tells it's more connected to water, clean water and sanitation. Okay, again, all the goals, they are connected directly or indirectly, more closely. this center point is very important in order to do this one. Then the next ring, all these goals are very closely connected. Okay, life on water, life on land, life below water, all that. Okay, remove the hunger, zero hunger, and the quality of life in the cities, climate action, all that. So they are very closely connected with water. So water plays so much of important role. And today, even climate action is also important thing in the UN Sustainable Developmental Goals. When we look into this, then what is happening today? What is happening? Impact of climate change. You see, this is the most worrying thing for the entire world today. This 21st century is experiencing, okay, which were not at all imagined. So today, the most critical thing is the climate change. We all have to focusly play our role. And if you see last 5 years, NASA data says that it has recorded the temperatures of the historical things. Okay, the last 5 years, globally, the temperatures are seen going very high. This year also we are experiencing. We have seen very recently Canada, where more than 50 degrees centigrade, some places it recorded. So the main effect of climate change, when we relate to water resources, okay, water is going to be very important component that's going to be affected by climate change. Oh, this climate change is affecting our hydraulic cycle. So the hydraulic cycle itself is getting influenced or it is disturbed by the climate change. So with the rise in the temperature across the globe, we have seen the post this industrial era. From that point, okay, pre to that time of industrialization to till today, average 1 to 1.5 degrees centigrade rise in the temperature is experienced. So that tells what? When the temperature is on rise, the evaporation increases. When the evaporation increases, some places it takes more moisture, some places, and some places gets dried up, some places more rainfall. It's going to affect globally. So that scenario we are seeing today, and this is causing floods in some places, droughts some places, melting of glaciers taking place, and sea level rise also happening, and the storms all we are experiencing. This picture is recent floods in China. Okay, which that magnitude of the floods they have not experienced over at least 1,000 years. Similarly, the drought in California, what we experienced in recent few years, it is also like never experienced more than 500 years. So such is the scenario right now, what we are undergoing, which never imagined. We are seeing all that in front of our eyes. Then how can we manage our water for agriculture? That is very important. And the projections also, okay, we have IPCC reports and different scenarios have been projected, how the water is going to get affected due to the climate change across the globe. Some scenarios indicate favorably to some countries, okay, they get more rainfall, some places is going to decrease, okay, then when it is going to get more rainfall again, that's the intensity is increasing, and accordingly you need to change your infrastructure management plans, and we need to control a lot of things, flood protection, all that. That's again creating a lot of problems. The same magnitude of rainfall is going to happen in lesser number of days. So this is also scenarios. Okay, I'm very glad today a lot of institutions are doing quite a good type of research, good amount of research, and many institutions are doing that, sharing their experiences across the globe. This what is the projected scenarios for next 50 years, 100 years. So taking all that into our consideration, taking how much we can observe to prepare our future plans, that's the agenda for us. And it's also going to affect the agricultural productivity. Okay, and across the globe, some scenarios says that India is going to get affected by 2080 largely because of the increase in the temperature and the change in the global climate. So the yields are going to get affected. Okay, so different scenarios are giving different versions. Okay, still India will be at loss when we see the crop factors, all that. That's what we have to pay real attention. And now why we need to pay more attention is that the demands for water for agriculture is increasing. Okay, the water demands across the globe increasing for all the sectors. Okay, particularly when we come from India, when we see India, we need, because growing population needs more water, and the projections by different agencies like FAO has given the scenario by 2050, what is the amount of water required for our food. So now many countries are worried. Where comes from that much water for agriculture? Because the demands are increasing from other sectors. And okay, across the globe, average 70% we are spending. Some countries like India, we are spending 85 to 90%. Some places we are spending. There are many countries more agriculture is required. Then how can we manage this? That's again a concern for us. And okay, for every country, the water scarcity, raising the demands are issues. But for India, we have a special concern that our population is growing much faster than anything. So that is one really worrying factor for India, because we never imagined we will be close to China population by this time. There was some lag, but now India is marching very fast. And this added increase in the population is affecting our per capita availability. So how much difficulty we will be experiencing next 50 years in India? Imagine, as per the United Nations recommendations or UN water, how much is required per person per year in India? Today, we are not having that much water. Apart from that, from 300 million tons of food production today average, and we need to go to 450 million tons by 2050. So Palani Swami can throw some light on this. And we have again targets. That's the one important thing from our national policy, tells that we should improve the water use efficiency across all the sectors by 20%. So keeping these challenges and opportunities, how we have to go is we have to decide. And largely when we talk about irrigation water management, we have built a lot of irrigation projects in the country. A lot of projects are there. When these projects we built, okay, keeping a lot of our resources there, and we create a water potential, okay, water resources, but how much actually really effectively used? So the average efficiency in any project should be 60 to 65%. Okay, if you build a big project, 100 units of water is stored in the reservoir. At ground level, we have to use at least 60 to 65%. But we did quite a lot of research, okay, a lot of studies, okay, across the country, and voluntary led a number of projects, studies. We found the average efficiency of the projects in the country is 40%. So here again, a big issue. How the efficiency is so low, what we can do. Particularly, it comes to on-farm water management. So that's what I would like to tell. At on-farm level, what are the initiatives we have to take to improve the efficiency? So how to empower the farmer, what type of land preparation is required, what type of scheduling we have to do with reference to the climate, what is the amount of crop water demand, how we have to deliver that. So a lot can go there at on-farm level. And again, we focus on on-farm level. You see that when the water moves from the source to the field, there will be loss. This particular picture I like so much. Okay, why? So we take water from the reservoir, it goes to the farmer field through a network of canals. When it is moving from source to the field, there will be losses. The major loss is happening at the farm level. So there we have to apply all our effort, not at the main canal or branch canal. But when we are doing project modernization, a lot of effort goes in the main canals, branch canals, not at the farm level. Here comes on-farm water management, engaging the people, attending to many things, okay, crop water demands, all that we have to work here to improve the efficiency. So now, as I said, we have built a number of projects in the country, okay, a lot of projects, and continuously we are building irrigation projects with but when we are running them, the efficiency are low. We try to evaluate a number of projects from when I was at voluntary. Earlier also a lot happened, but we also took some initiative. So going to each project, studying what are the issues, and then planning how to conduct the real studies at the field level. This again, okay, interacting with the farmers, okay, visiting the field infrastructure, and then what is the measurements we have to make, all data collection, then analyzing comes. So one important observation what I would like to tell, that we build the infrastructure, but maintenance certain times it is an issue. Okay, that asset management plans are very much important for any structure or any project. Similarly, water management also, asset management is a must. Then only we can have regular proper operations. So this is one observation we made, and we communicated to the government of India also. We have to put a lot of effort there. This national water policy, I'm very glad. So India, we have the policy since 1980s. but this is the revised policy in 2012, about 9 years ago. So then comes what is the priority on water use. The priority as per the UN we have to follow. The first comes to the domestic sector, then comes agriculture. So agriculture gets next, but biggest amount of water we use for agriculture. Here again, our priority as per the today's requirement. So climate change aspects have been also incorporated in the policy. And then the most importantly, demand management. So when we plan for delivering water as per the crop demand, so then you will be considering all the factors there. Today, certain times the water is supplied because we have water. But if you take the demand at crop level, then what are the sources available? Rainfall and your canal water, groundwater, and then if you synchronize all the three components and deliver, provide to the crop, then we will have better management, the demand management. And this also speaks about water footprints. That's very, like I said, even virtual water component. Recycling and reuse. This is again important thing. Incentivizing economic use. So this again is very important. Suppose some farmer is spending less water with all the technologies are adopting, and they should get some incentives. That is also embedded in the national water policy, and adoption to water saving practices, okay, and monitoring the performance. And today I'm glad that the government of India, we have various water resources information system where all the data is available of different river systems, different basins. So that is helping a lot of researchers to do things. And again, one more area is the reclamation of the waterlogged and saline lands. So today, a lot of projects we are over irrigating, the waterlogging conditions are being experienced. How to do that is again important thing. For out of all, when we want to do these things systematically, we need to have the institutional support. Okay, we have like Walmis, Valamtaris, okay, about 20 institutions in the country which provides. They need to be sustainably supported to do this service, and regularly capacity building is also required. And this water footprint approach, why it is required? Because we need to plan, okay, how much is water available and what are the demands and how this to be managed sustainably, regularly. So we need to go and what to be exported, imported, all that happens based on your water footprint calculations. So then today, today order is that maybe in another very decades time, all what is going to be in the market will be labeled with a virtual water component. How much water goes into a product, what we consume, or the service what you take. For example, a kg of rice is going to take 3,000 liters, world average today. So today in India, we have some farmers who are producing the same kg of rice with 1,500 liters. And but in some projects, we are spending more than 4,000 liters also. So now this is how they are going to get incentivized if we bring that marketing by labeling the water that goes into the kg price for the amount of water saved, we can transfer the incentives to them. So this sort of things can also happen. When the farmers are taking less water, they need to be incentivized. Okay, like some places in the world, so where this water credits are being given, and that can be converted into monetary values. So let us see that how best we can encourage the efficiency, and at the same time, the people who are contributing for that, they get incentivized. In order to do these things, okay, if you want to invest on this, if you want to improve the things, first we need to understand the value of water. I'm very glad that Dublin Principles has given us one principle as valuing the water. So that is very important. Okay, how much the water costs to you is important. Okay, if you are irrigating paddy in 1 acre, how much the farmer pays? Farmer will pay 200 to 300 rupees or maybe 150 rupees. Okay, maybe $3 to $4 in terms of dollars for irrigating 1 acre. But if you charge 1 paise liter, 1 paise liter is means 1/100th of a Indian rupee for the international participants there. So if you are charging 1 paise liter, it costs 1,20,000 rupees to irrigate 1 hectare of paddy, means $2,000 for irrigating 1 hectare of paddy. Okay, similarly, for 1 acre, it is $800. So I think even American, European farmers also find it difficult to pay like that. So that is the value of water. So much of water we take for agriculture. That's why here a lot of efficiency should go, and the water saved can go to the other sectors. So that's why today all the technologies or the best practices have to go to the farmer field to save this water and share this water for the other competing demands, growing demands, where we can get more revenue for this one and value for this and the sustainable development goals all we can achieve, provided if you understand these things. So this is one initiative. Yeah, how this climate change, okay, measures we really adopted in our state of Andhra Pradesh over last 1.5 decade when we did AP water management project, funded by FAO in the states of both AP and Telangana at that time. So we have seen that this is arrival of water in the canal is coming late, okay, in the Krishna Western Delta. Then the crop season is getting late. So then what we tried through our research, going for the dry seeded paddy, okay, direct seeded paddy. Okay, once after monsoon, you can grow the paddy by seeding the paddy seedlings, the paddy seed directly, okay, not the seedlings. Just this is through seeder, you can seed it. And then after some time when the canal water comes, then we convert that into a wet cultivation. So like that, the farmer will be saving a lot of money for transplantation purpose, and just it grows very well. And provide if you manage the weed management in one issue here, we are having a lot of ways to manage the weeds also. So when we grow the paddy like that, farmer will get at least maybe 5 to 10% increase yield if we do very well, and otherwise you get equal yield. That's what is our research, and a lot of large scale implementation we did. And but we are saving 30 to 40% of water. So this is a biggest change that happened. Today, lakhs of acres in the Krishna Delta, the farmers around Vijayawada, Krishna, Guntur district, even Godavari districts, even other districts of state also, even Telangana, many people are doing it, direct sowing paddy, because that's how the river, the water flows into the canals got delayed because of the delay in the supplies, or because of change in the rainfall pattern in the dam catchment area. All that led to this development, and the farmers are really getting experience. Like that, lot of things are possible where we can do. And here we also try to do at farm level what we can really do. Okay, the paddy doesn't need standing water. Paddy doesn't need standing water. The research has proved it, but we need to have the enough moisture in the root zone. So in order to ensure that there is enough moisture, so even a water table goes 5 centimeters below the ground level, still due to capillary, the plant gets water. So to ensure that the farmer get understanding of this, these Bowman tubes installed, driven into the ground, and with the help of the scale, we can measure the depth of water. When the water table recedes from the ground by 5 centimeters, you irrigate again. So to help the farmer, we use the ICT, okay, tools, okay, sensor-based data transfer that can go to the farmer mobile, and he can see what is the data in his field, what is the real scenario in the field. So this situation tells him 2 centimeters the depth of water in the field, the temperature that day at that time is 30 degrees, okay, relative humidity is 50, okay, lot things can be measured with the sensors. And the farmer seeing sitting at his home, he can see his on mobile what is the depth, 2 centimeters. There is no worry to him to go to irrigation. So once it comes to 0, then -1, -2, -3, or sometime he can, at -3 he can get alerted. Next day he can go and irrigate. So this way again, if you do it, it saves you 30 to 40% of water. So these are certain things which we can take it for the large scale implementation. We implemented a project called Clima Adapt with the funding by Norwegian government and the states of Andhra Pradesh, Telangana, and Tamil Nadu. So where these interventions we made. And the same thing, we can use the sensors for measuring the river flow or canal flow. Okay, time to time we can get what is the discharge, what is the depth. If you have the rating curve, we get the discharge. So such interventions will really help us. We can do. And now, most importantly, what we have to do is, it is not that we only train the old farmers. Okay, of course they are the farmers, we have to go them. Okay, but if you want to really change, let us change our system of trainings and our knowledge sharing with the children. So while at Voluntary, we took initiative to reach the children and adopt a number of schools. There we created interest among the children, measurement of water, and how the sensors works for measurement, what are the flumes available, how the flumes can be used for measuring this one. So slowly they got a lot of interest, and we gave some competitions, and we conducted water schools to the elders with involving the children. And that is one big area, really opportunity available for us. to educate the children at school level about these natural resource management, because they are our future. They will be there in agriculture industry everywhere where we want to save water, improve the efficiency. So we on sensors assembling also, we trained them at the school level. Now, when we see the good practices, okay, the micro irrigation is one important thing. Okay, today across the globe, so micro irrigation is catching up everywhere, and India leads the world almost. Okay, India is competing with the major countries. It started with Andhra Pradesh micro irrigation project in 2003. That's the biggest comprehensive micro irrigation project ever taken in the world, involving the farmers, involving the bankers, involving the companies, and that made a big change. Today, I am happy to tell today there are farmers, they don't want to plant a tree in some of the states without drip system. To that extent, these projects, we have Gujarat Green Revolution Company project. Many states have their own projects. Andhra Pradesh and Telangana have the projects, and this has made a big change. And we have that helped us to get a lot of fruits and vegetables in the market today. The micro irrigation has really contributed. All these experts, they know what's happening in India today. And I have visited, because I was a technical head for the project for 5 years, visited all the farms. I got a lot of benefited seeing the farmers in India. In fact, we have almost half of the area which is cultivable can be converted into the micro irrigation. That much potential is there. So we have about 69 million hectares potential. The National Task Force on Micro Irrigation in 2003 has presented a report which tells half of the area that we are planning for irrigation can go into the micro irrigation. Yeah. Now today, when we see, it is not the individual farmers, even canal irrigation. Okay, what we did in AP micro irrigation project is targeting the farmers having their own bores, their own pumping systems. Now it is not that individual farmers, as a group of farmers under the canal system, the micro irrigation has to be taken up. The government of India today made every project in the country should have at least 10% of the area under micro irrigation. All lift projects are to be converted into micro irrigation. Whenever you are lifting the water, it should go, because we are energizing that water, that should be efficiently used. So with the micro irrigation, a policy should also come like this. Today we are building up many projects with a lot of pumping, again gravity irrigation. So there will be a lot of loss. Okay, a policy should also be there. Whenever you are lifting the water, it should be essentially a micro irrigated. Okay, like that, for which all the designs we contributed. And it's not only that canal water, we have a lot of scope and use of recycled and reused water. Okay, we produce a lot of wastewater. Okay, the cities that can be treated and effectively can be used. First of all, we have to have the treatment capacity for all the wastewater. Then that can be. Today, Israel leads the world in terms of reuse of the wastewater and recycled water. And they have entire country, they have the pipe network where the fresh water will have a different pipeline. This one reused water, okay, recycled water will have a different pipeline. Farmer can take that one, accordingly that will be charged. So India has a lot of scope in this area where we can use that. Today we have only capacities for 50% of the treatment. For a treatment to capacity is only 50%. For the waste, we create wastewater. We have to put a lot of effort there to make it this thing. And as I said, the demand management, when it comes, this is the responsibility of all the departments. Department of Agriculture, Department of Irrigation, okay, Department of Horticulture, universities, farmers, all put together, they have to take part in the agricultural water management. So this sort of approach we practiced during our projects, trying to educate the people. Now, when it comes to ICID, our president has already mentioned that ICID is one working towards meeting the sustainable developmental goals along with the international partners. I'm glad to be part of it for last more than 12 years, okay, more than 13, 14 years, and meeting so many experts in this. And in order to encourage better water management, okay, better systems to be placed at the field level, okay, better practices. So ICID has introduced awards for the different areas. What's your technology award? What's your management award? best work bodies like that. Okay, in order, because we are all here to contribute for that sector. So in order to encourage this thing is encouraged by this one. And I want to share that this year our country, okay, got 4 World Heritage Irrigation Structures awards. This is the first time India got 4 number. Out of 4, 3 we got from Andhra Pradesh, from which state I come. Okay, this goes to all of you. Okay, because when we have these structures which are more than 100 years old, still working, we have to pass on this to the next generations. I am very glad and proud to be part of ICID, recognizing the irrigation structures or related structures which are more than 100 years old. This year we got Best Farmer Award also to our country. Okay, who is really doing very well. I have visited this farmer twice. And also we got Best Paper Award for the work we did under Climate Adapt project. And ICID, in order to promote these activities across the globe, okay, we have the congresses happening once in 3 years, and World Irrigation Forums happening once in 3 years again, and Micro-irrigation congresses, okay, which happens again at periodical interval. Similarly, drainage workshops, okay, and every year annual workshops, International Executive Council meetings happens. So the latest was we had in 2019 this Micro-irrigation Congress in Aurangabad. So like that, ICID is putting its efforts in promoting these things and to ensure that all the countries work towards these developmental goals. And future events, okay, what ICID is having this year end, again we have International Executive Council meeting and African Regional Conference in Morocco, and 73rd, the 24th ICID Congress, which was supposed to be held in 2020 in Sydney. Now it is postponed to 2022 in Adelaide. And we have World Irrigation Forum, which was supposed to be held in 2022, is shifted to 2023 April in Beijing. And I'm very glad that the 25th Congress of ICID and the 75th IEC, International Executive Council meeting, is coming to India. This Congress is coming to India in 2023 in Vizag. And this Congress is coming to India after 57 years. So I'm very happy to share, and we will be inviting you all. And then the 5th World Irrigation Forum is also happening in 2025 in Kuala Lumpur. And ICID always takes pride encouraging the young professionals, children, okay, young professionals particularly, and sharing global experiences with them. I'm very glad. It's really very fascinating to me to see that so many people, so many professionals contributing across the globe to transfer their knowledge to the young professionals. I always take as a participant and organizing things on behalf of the ICID at the global platforms. And the youngsters who are attending here, you can get into the ICID website and see the opportunities available for you. You can also register the young professionals. And this is coming to an end. Okay, this is the Congress where it's happening in Vizag, the most destiny city of India, we say, and a beautiful coastal place, and the beautiful place. My international friends, so who are there, Marcos will be mobilizing a lot of international gathering to the Congress. This is going to be unique thing. Okay, our young Chief Minister has given all the support. Government is funding 5 crores for that. All the support. The government has also nominated me as the organizing secretary. We are taking all care. So we will present later sometime in future. Okay, with this I'm coming to an end because I have taken I think 40 minutes. Okay, at least 35 minutes. Okay, let us see that in order to ensure that the sustainable management happens, let us understand what is economic good. It is not free commodity, and water measurement is important. Okay, any resource which cannot be measured cannot be managed well. So here we have different devices to measure it. Demand-based delivery we have to make, and this virtual water approach. As we cannot go because the big topic. Incentivizing the water efficiency, who are investing to adapt to the climate change patterns, or improving some practices, or who are going for modern methods of irrigation. Government is giving incentives, definitely giving some subsidies, etc. And irrigation asset management. This is again important. Finally, it is collective responsibility. They participate in irrigation management, and here water should be management is everyone's responsibility. With this, I thank. Okay. And I conclude my presentation here, and I'm available for discussion. And I think that we have very eminent panelists there. Eminent panelists, as I said, Dr. Palani Swami, Dr. Marcos, and Anshuman. We need to see their remarks, their presentations also briefly. And at the end, we can take the questions, I think. Varma Garu? Okay, ICID central office. Otherwise,
Yeah, thank you, Dr. Reddy, for
yeah,
a very
please.
good presentation. We have received number of questions as well as comments. You can see questions in question answer box, and if you wish, you can give the answer in writing also. You can answer
Sure,
the
sure.
question through there, and otherwise we'll take up some of the questions in the end. But I'll just take two questions here because they are just relevant at the moment, because one person, Mr. Rafat Al-Intaki, has asked that what their children are doing in the picture. So you can just clarify what children were
What
doing in
children,
the picture.
what children are doing in the picture, okay?
Yeah, yeah.
Yeah, the children, the school children, we have taken from the school to the field, and we have shown them how the water can be measured with the flumes, okay? Because they should know how the water should be measured. And the second part is what is the sensor. We use different sensors for measuring the water table depth and also temperature, humidity. We shown them, we gave the first time exposure to them, what is the sensor, how that should be assembled, because we have a team at Voluntary who are doing all that networking, etc. And they were very impressed, because otherwise they cannot see the things. I'm very glad we could able to expose the students, the school children. At least we trained we reached 5,000 school children in the project area. And every year we used to conduct some programs for the school children at Voluntary, conducting water weeks. So that way we used to encourage. Okay.
Yeah, and then another question which I like to take at this stage, rest will
Yeah.
take at the end. Mr. Dr. Chris Perry has asked, what are the units of water use efficiency in your presentation? Because you are talking about water use efficiency, but what are the units? So he wants to get a clarification, but he has number of other comments and questions also, which we can take later on. But
Sure.
I thought that let us get this question here itself.
Yeah.
And we may give chance to Chris Perry also to speak in the end.
That's wonderful. Yeah. This efficiency that depends upon the at what point we are measuring. Okay, water efficiency is okay when it comes to the field level. Okay, yield per unit of water will come, yield per unit. But when we are seeing the conveyance, storage, distribution, it is a percent. If you deliver 100 units, how many units are reaching that point? Okay, so different ways we can present, but this is largely percentage of water. Okay, you said 100 units of water there. When it is in the reservoir level, if you store 100 units, the efficiency is 90%, means 10% loss at the reservoir level. Then similarly in conveyance, distribution, like that. But when you see the water productivity, there comes the kg per how many liters unit, like that we can define. Okay, we can discuss again, I think, at the end also.
And another associated question from Chris Perry is that presentation is confusing. Water applied with water consumed. Rice consumes around 1,000 liters per kg. The figure is 3,000 liters. Water applied, rest is recycled.
It's not like that. Okay. Rest is recycled means now you see.
He saying that you showed 3,000 liters of water per kg. So he's saying that 1,000 liters are actually consumed, and rest is recycled when it is going to the seepage and groundwater and things like that.
That we can see that in different perspectives. Okay, what I want to say, when a project is constructed, the objective is to irrigate so many acres. We prepare the project plan. But if you over irrigate and if the losses are more due to conveyance or application and runoff, so we say the water is recycled. It is available in your system. It goes somewhere into the system, but it is not we have lost the efficiency of the system. That is one part. Okay, again, how much there 3,000 liters? What I said, the global average today per kg of rice, globally average around 3,000 liters. In some places, if the farmer is pumping his own bore water, he is doing more carefully. He is producing same kg with 1,500 liters. Suppose in the delta area where the canal is carrying water, there is not much care. Sometimes it is 4,000 liters we are spending. But I also agree, but this is a dispute always. So the water is not lost. It is available in the system somewhere. Okay, it is going to the groundwater or it is going to the drains, like that. But here, when it comes to the efficiency, we have to see under the framework, what are the guidelines when the project is designed, what is contemplated, what we are doing now. So a lot of things can come there. Varmaji, I cannot, Terry, I know. Okay, Terry knows the things we can
Yes,
discuss
Dr.
again.
Reddy, what you can do,
Yeah.
you can, if you wish, you can write to him, and you can, through chat also, direct message, you can also discuss with him. So we'll take
Definitely.
some of the questions in the end. So
Definitely, I love to share, and I love to also listen from our eminent panelists also there. Okay, Dr. KP,
now
etc.
I'll request Dr.
Yeah.
Marco Hasri
Yeah.
to give his presentation. And Dr. Reddy, you stop your sharing of screen.
Yeah, I'm doing it. Okay. That is very wonderful. First, let us give time to Dr. Marcos. He wants to make small presentation, I think. Similarly, Anshuman also some presentation. And okay, if they do their presentation 10 minutes each, then okay, let us do like that, I think. We go with Marcos, I think, first.
Yeah.
Is it?
Dr.
Okay.
Marco?
Okay, thank you. I'll start sharing my screen. Can you see it?
Yeah, fine.
Okay, very good. Okay, good morning, good afternoon to all of you, and thank you very much, ICD Center Office, for inviting me. Thank you very much, Professor Yalareddy, for inviting me to be a panelist in this interesting and very important international webinar on climate smart agriculture, water management. In this presentation, I will try to stick to the 10-15 minutes I have been assigned. I will just show very quickly what is the state of the art in Italy, what we are doing at the moment in Italy on these topics. So let's have a look very quickly what is the framework, legislative framework. We have had since Italy was a reign, we had in 1933 the first royal decree, but then very important law, first important law is the 183 of 1989, because with this important law, which actually grew after a very dangerous, a very serious landslide, we have been instituting the river basin authorities. Then so many other important laws on water use management, and the important European directive is the 2060, which gave birth to river basin districts. And the other important European directive is the 2007, which is regarding flood risk management plans, which has been accepted and adopted in Italy in 2006. And then very important law is the 13 of 2009. As I said, by adopting the the European directive of 2060, we have passed from river basin authorities. We had more than 40 basin authorities, 7 national level, interregional level, regional level, and so on. We gave birth to a new system of the river basin hydrographic districts. There's 8 of them all over Italy. And I am currently working in this one, Southern Italy, Apennines River Basin Authority. Let's see, very quickly, what is the establishment of the Water Framework Directive, adopting an innovative approach for water management based, as I said, on river basins. The river basin management plan should be based on environmental restoration, public participation involving all stakeholders, hydraulic security, landscape restoration, and the final goal should be to achieve a good status for all of the Europe's surface waters and groundwater. Of course, this is a major challenge because some recent assessments estimate that at least 40% of the EU surface water bodies might be at risk of not reaching this objective. The other important directive is the 2007 regarding floods, which are natural phenomena, which cannot easily be predicted. Very much connected to climate change and human activities. This directive requires member states to assess if water courses and coastlines are at risk of flooding and to map flood risk. In Italy, the directive has been transposed into the Legislative Decree 49 of 2010. So, according to this directive, all European countries must prepare a flood risk management plan, which must be focused on prevention, protection, and preparedness. It should take adequately into account the maintenance and the restoration of floodplains, as well as consider measures to prevent and reduce damage to human health, environment, cultural heritage, and economic activities. All of these must be periodically reviewed, and if necessary, they must be updated, taking into account the likely impacts of climate change on the occurrence of floods. Another important aspect of this directive is the hydrological management plan, on the other hand, which analyzes all major rivers' hydraulic hazard and deals with risk management. So, coming to irrigation. In Italy, irrigation, of course, is one of the most important inputs for production. It is absolutely indispensable, especially in the southern part of Italy, whereas in the central and northern Europe can have a less important role. Of course, it is essential to mitigate effects of climate change, enhance quality of production, stabilize crop yields, grow high crush crop, increase competitiveness, and improve economic conditions. So it is essential for Italy. As a matter of fact, 2/3 of Italian exported production comes out from irrigated agriculture. The challenge, what is the challenge even for Italy? Over the next 20 years, as we all know, population will grow in another 1.6 billion people, and food production will need to double. But the challenge will be to increase production without further reduction of forest, environmental damage, reducing pollution due to fertilizer and pesticides, and without, most important, any upsurge in use of good quality water. So, what is important to state is that irrigation efficiency will become progressively more and more important in order to increase yields of crops and agricultural food production. So, food security must necessarily be accomplished by improved irrigation efficiency. How can we achieve irrigation efficiency? It must be sought all the way from source to plant, reducing non-positive losses with technological strategies. So some of the economic strategies regarding time of irrigation and amount of water to give are essential to determine high physiological efficiency of water distributed to the plant, what we call more crop per drop. So we can seek for efficiency in water conveyance and distribution, major efficiency in irrigation system, in irrigation scheduling. Very quickly, main solutions that we have been using as Italy in the past 20 to 30 years, canal, of course, more efficient canal lining and waterproofing, replacement of earth canals with pipelines, functional restoration of steel and cement aqueducts, replacing them, use of long duration and low maintenance pipelines. This can increase, as we have been witnessing, increasing of efficiency during the phase of conveying and transporting water from 20 to 50% in some cases. Another important aspect is innovation. Automation of control and management, as you can see here in this figure, allows an efficient control and management. It can be achieved by means of sensors measuring the parameters such as pressure, water level, flows, and so on. And all data are collected in order to obtain the best possible management of peripherals. Another important aspect talking about innovation is the geolocalization of activities carried out systems in the field, on the territory, which can bring us to an overall improvement in the management of the water resources. Another important aspect we have been working on, especially in the northern part of Italy, with the Canale Emiliano-Romagnolo, which is an irrigation consortium. They have been studying on the automation of the delivery network. This slide here shows an example of how gates and sluices can operate as a result of crop water requirements and irrigation scheduling provided by some expert systems such as the IRINET IRIFRAME, which I will be very briefly describing further ahead. This is an example here of a photovoltaic feeder energy gate with remote control and automatic flow rate or level regulator. It can interact automatically with other sluice gates and sensors or to control an entire canal or channel and a basin system. Another important aspect regarding automation is the control of automated water delivery groups. They are working, some of these, this is an example here, this is in Foggia, in Capitanata, in the southern part of Italy. They can allow for fair distribution of water and cost sharing, correct water charging according to shared utilities. Of course, the price here is based on water consumption. So water tariffs here is based on water consumption. So we can achieve possible regulation of water, turnover among different delivery groups, and reduction of non-useful withdrawals. The farmer, as you can see here, each farmer is provided with an electronic card, and he has a credit of water he can consume all the way through the irrigation season. If he needs more water, he will recharge with an additional price, an increase in price, of course, in this case. Another advantage of these systems is the remote reading, so we need fewer employees and lower operational costs, telephone alarms in case of failures, emergency service, and remote suspension of the supply in case of drought or defaulting users. Talking about innovation, another important aspect we have been dealing with, especially in this irrigation consortium of Emilia-Romagna, is installing of photovoltaic panels on pumping stations, on irrigation tanks, and on canals in order to reduce energy costs, which is what you can see here in this slide. Now, irrigation efficiency can be achieved. For instance, we have been, as Italy, a lot has been done on sprinkler irrigation, now mainly carried out on big self-propelled irrigation machines such as hose reel, or very large machines such as pipe wringer, especially in big farms. All of these have been recently innovated with rainwater control and regulation technologies combined with low energy need water irrigators. Of course, these new kind of irrigators have greatly improved water distribution and have increased uniformity efficiency. An example here is shown in order to improve irrigation efficiency, especially on large machines. Sprinklers have been replaced with low energy precision application devices, LIPA. Water losses due to drift and to the distance existing between the nozzle and the soil have been greatly reduced. And the advantages achieved by replacing traditional sprinklers can bring to efficiency higher than 90, have been witnessed higher efficiency higher than 90%. Another important aspect if we shift from sprinkler irrigation to micro-irrigation is the so-called ultra-low drip irrigation. What is the difference with traditional micro-irrigation? As you can see here, when we have traditional micro-irrigation, useful water is in the upper part of the soil, and there's some part of the water which gets lost. With ultra-low drip irrigation, we only have available useful water. This technique is due to the very, very low flow of water, 0.1 to 0.3 liters per hour. There's a longer period of water release, so water is released very slowly. Inputs can be synchronized with water demand. There's a higher efficiency for the plant. There's a lower water tension in the soil. There is no percolation, excellent water saving. So mainly, water applies at a low rate over a longer time and with more frequent intervals. This is the reason for dealing with only useful water. Water is applied at or near the root zone, and emitters discharge the water from the distribution line directly into the soil. And you can see some of the consequences of this ultra-low drip irrigation. For instance, if we're talking about weed control, as you can see, there's a difference between traditional drip irrigation and ultra-low drip irrigation. So this is also a very efficient mean to control weed. And there's a higher, as I said before, water distribution efficiency, as you can see here, for ultra-low drip irrigation and traditional drip irrigation. Talking about water use efficiency, which is measured as grams of biomass per liter, but it can also be, of course, depending on the scale, can be measured as kilogram of dry mass per cubic meter. In this case, as you can see, if we apply with ultra-low drip irrigation 70% of evapotranspiration, effective evapotranspiration, there's a higher water use efficiency compared to traditional micro-irrigation, which gives actually very low difference. As a matter of fact, if we apply here, you can see 30% of the seasonal volume, which is about roughly 1,500 cubic meters less, we have the same yield, so have a higher water use efficiency. Compared to traditional drip irrigation, if we apply 70% of seasonal volume, the yield has been 20% less. So, and coming to soil moisture, another advantage of ultra-low drip irrigation, soil moisture level in the soil remains very, very stable. Whereas on the other hand, with traditional drip irrigation during the growing season, we can see that there's a decrease, of course, of soil tension, water tension. Now, IRRIFRAME is the technical, talking about irrigation scheduling, technical systems on irrigation scheduling. It's an expert system. This is an expert system, IRRIFRAME or IRRINET, which has been developed by means of UE funds. It provides farmer information on the following parameters: crop water requirements, irrigation interval, and frequency. Has been very helpful in increasing quantity and quality of agricultural production. It gives, as I said, real-time irrigation scheduling. Data are gathered on a daily basis on the web database server from several sources, meteor farms, agrodata networks. And irrigation scheduling is conceived and built by means of an irrigation model based on daily water balance. It has been developed by Irrigation Consortium of Emilia-Romagna, as I said before, and it has been validated over 30 years of field trials. The model is run on the web server. Every time the user clicks for information, so latest data are always taken into account. This is a slide just to show, here are the inputs: crop data, irrigation systems, meteor data, soil data, water table, and consortium data, of course, irrigation consortium data. So the system, the expert system, runs a crop water balance and irrigation schedule according to intervals and water availability. What is most important is that after first time, inputs are automatically assigned by the system. So it provides timing of irrigation intervals and frequency, irrigation volume, and also, if requested, can give the threshold of intervention for the economic convenience to the farmer. These are the information required to run the water balance, meteorological, soil maps, with all this information, which you can see here in this slide: farm georeference data, meteorological data, all layers of information, water table data, soil data, crop parameters, irrigation districts, of course. So it can be easily accessed by internet or provided to the farmer, directed to the farmer by WhatsApp or SMS messages. What the irrigation consortia who have been adhering to this expert system need to have is to acquire georeference data on irrigated areas, the irrigated areas of the farmers and inside the irrigation network, and provide information on irrigation intervals and conditions. It can be accessed by entering the National Association of Irrigation Consortia website or directly from the Irrigation Consortia website. So each farmer who is part of the irrigation consortium is provided with a password, and he can receive the irrigation advice on his phone, on his wherever it is, his device, telling him how to irrigate and when and how long and so on. So the user, as I said before, will access the service introducing his georeference data of his farm on Google Maps. The system will automatically provide up-to-date information on the irrigated area, meteorological conditions, water table, and soil characteristics. This is an example here of what is the system looking like. So you click on the map to find the user farm, and you can download the following data: meteor database, pedological database, water table depth, water board, and so on. Some of the soil moisture data are provided in connection with the IRRIFRAME system by means of soil moisture sensors and data loggers. So you can input some of this information if you have, and the system will provide you with this type of graph, which it gives you and returns the irrigation advice. Now, this is a typical irrigation output page. Here you can see the crop. I'm sorry, it is in Italian, of course, but you can understand this is the crop. This is, for instance, it gives you the predicted evapotranspiration for the day. It gives the next following irrigation day useful for irrigation, and it provides with irrigation volume and duration of the irrigation. And of course, after you have been irrigating, it gives you also confirmation that you have been using the advice. Is available in most of the irrigated, this system is available in most of the irrigated areas of Italy. In case trying the service outside covered area, the application shows a pop-up message of warning. So you can touch the try demo GPS localization which will be overridden by standard Italian localization. And you can select the crop touching the crop name. This is an example of a field trial that has been carried in the past. As you can see, talking again about water use efficiency. When the farmer is using irriframe, you can see that the yield is much higher than the one provided by the farmer advice. And in terms of water loss or water saving, you can see that there's a very consistent water saving, about 30%. This is on average provided by irriframe advice compared to the irrigation scheduling provided by the farmer. And in terms of water use efficiency, as you can see, the water use efficiency provided by adopting the irriframe expert system is much, much higher compared to the one provided by the farmer. It is, this system is regarding, as of now, as of today, almost 2/3 of Italian irrigated area, 15 to 25% of water saved, 1.6 to 2 million hectares involved at the present day. The way ahead, and I'm leading to the conclusions. What is the way ahead? Precision irrigation at variable rate is the new approach that Italy has been trying to achieve. There's a lot of information regarding differences existing among different areas of the field in terms of soil texture, moisture, physiological state of the crop, which can allow to intervene in a differently calibrated manner. This is very important in order to improve yields and using water inputs. Some of this data, of this monitoring normally takes place by means of satellites or drones. In other cases, can be carried out directly on the ground by means of large machines such as Pilot and Ranger, where these cameras can be applied. And they are provided, as a matter of fact, with specific devices or technologies enabling control of the sprinkler flow according to the needs of the cultivated microzone. Now, Consortium Emiliano-Romagnolo, which is this irrigation consortium, very advanced, technologically very advanced in the northern part of Italy, in Emilia-Romagna, near Bologna, has been carrying out some experimental trials by means of this Aladdin project in order to verify possible application of variable rate irrigation, acquiring spatial data obtained using drones, as you can see here. What is important is that the combined survey of multispectral sensors calibrated to determine the normalized difference vegetation index associated with thermal infrared data for the determination of crop water stress index can allow for a very efficient analysis of the different situation existing in the same field or in different fields. This is based on the condition that, for instance, as you can see here in this graph, healthy plants usually reflect very little in the visible part of the spectrum and a large part in the near infrared light. On the other hand, stressed plants reflect a little more in the visible part of the spectrum, in the red part of the spectrum, and a little less in the near infrared. So, by means of this analysis, it is possible to apply different irrigation application in rates in the same field. For instance, this is an example here. As you can see, maize on this part of the field, and you can have tomato here, and you can see that there's a difference, of course, and this is another aspect. This is for maize, and of course, all this information can bring you to adopt different. I'm sorry for the Italian here, but you can understand. You can adopt different rate of irrigation, different amount of irrigation always by means of e-frame expert system. So the future, the way ahead is that probably in a very short future, georeferenced maps can help, can enable to differentiate irrigations wisely by means of this smart system, which is what is depicted here, as you can see in this slide. And with this, I conclude and I thank you for the attention. Thank you very much.
New innovations. Thank you, Dr. Marco, for a very interesting and useful presentation, which showed us how precision irrigation can lead to water, increased water productivity and increased water use efficiency and water saving. So now there are a number of questions are there which are specific to your presentation, because people are interested in knowing some more data or more thing about Italy. So what, because of time constraint, we'll first finish the presentations, then we'll go for the questions in the end. Now I'll request Dr. K. Palani Swami to give his presentation. Dr. Palani Swami.
Okay, thank you. Good afternoon to everybody.
Good afternoon.
Given the overall framework of the webinar on smart agriculture practices and the policies, my brief talk will be covering on the topic as well as some of the points already covered by Dr. Ella Reddy. Okay, so I will take about 10 to 12 minutes. Okay, in 3 parts. Part 1, I will cover first give a background story about climate change storyline. Second, about what are the technologies available as so far defined as a climate smart technologies. Then third will be to take up the technologies, what are the policies required. Okay, so look at the storyline. Everybody knows what the climate change and other things, but some rough estimates indicate because of the intensive floods and the frequent drought, particularly in India, most of the reservoirs may be facing some water shortage in the future. So rough estimate will be about 15 to 20% of the storage will be affected in the future. So on the supply side. In the demand side, there is an increase in the crop water requirement because of the increase in the ETO and also reduction in the effective rainfall component. So there will be net irrigation requirement may increase 5 to 7%. So one side there is a supply reduction, another side there is an increase in the demand. So there is a gap in the next maybe 1 or 2, 3 decades that will be coming. So the major question will be how to manage the expected water scarcity induced by the climate change. One best option so far debated or being concluded is the climate smart technologies. Okay. As such, my view on the technologies, water management technology is already embedded with the land, crop and soils. So with this only water management technology will survive and function. Okay. So the technology means everything is embedded. Okay. So if you look at the history of the technologies and the climate change, both are correlated. The technologies already evolved through water management research centers or individual some smart farmers are already modified according to climate change, particularly temperature change, rainfall, already modified. We did some experiment putting these technologies in different phases. For example, we use one IWCB ratio per irrigation scheduling, AWD, alternative wetting and rain. So when we compare this one, automatically some weather component is inbuilt so that farmers are already adjusting. So my conclusion is hypothesis, all the technologies already developed for agriculture and water management are already adjusted to the climatic change, maybe 90%. Okay, so the technologies are already available. So if that is the case, how to manage the future scarcity of, that's a question now. So if we want to keep the same level of production, food production, employment, etc., if you adopt these technologies in most of the irrigation projects, we can easily manage the scarcity. That's a one. We experimented in 3 major river basins, Godavari, Krishna, Kaveri. We did an elaborate experiment incorporating all the climatic parameters, yield increase, variability in yield, water supply, etc. So when we inbuilt in the model, it automatically, the protection level is sustainable in the long run also with the same level of water supply, provided the technologies are inbuilt in the system. So that is the conclusion we made through our research. Also, we did a ground truth by visiting some of the farmers' field. So wherever farmers are adopting the technologies, their water use or water requirement was much less. So that demand and supply more or less is easily met, provided the technologies are properly adopted. But one question will be, everybody will ask, when the technologies are available, protection can be easily met from use of technologies. What is the problem? The problem is what is the level of technology adoption? That is the biggest question put forth. So I am taking the inference from the already concluded a pan-India study where I have involved in a major role in implementing the program. There's a 5,000 location water management trials in 23 states. 67 research institutions were involved in experimenting all the water management technologies in the farmers field, 5,000 locations. So in total, we identified there are 402 technologies so far available in India in different states. So we spread that one. After the year, we found out only 22% of the technology has only reached the farmer, or farmer has access to the technologies. That's one conclusion. Then after the trials and the yield data and other things, we found only 10% of the technologies are only viable to the farmers. Okay, only viable. Even though technology adopted farmers, successful are only 10%. That's a little alarming message. So what are the problems? Problems are, major one was the technical know-how of the farmers. Farmers are not that smart to adopt all the technologies. Whereas the scientists are evolving the technology, putting forth for adoption, there is a mismatch in the adoption level. So one technical know, poor capacity building at the farm level was a major constraint. Some of the technologies are maybe too technical or too costly, they can't adopt. Some are too labor intensive, some are skill oriented. So these are the major constraints expressed by the farmer in most of the states. So that is the biggest challenge before technology adoption. So technologies are available, but upscaling and mainstreaming is the biggest constraint. So if we want to address the future climate change and the food production stability, technology adoption should be the prime mover. Okay. Okay, how to do that one? So in my third part of the policy framework, to make the technology adoption more successful, I am suggesting 3 broad areas. Okay. First one is refocus the research prioritization on technologies. But so far in the 70s, 80s, 90s, priority was given on the technology development. 90s and 2025 to technology management was given priority. But I feel from 2020 onwards, priority should be given for technology governance. Okay, what are the rules, regulations, norms, and other things one government or any agent should follow to make the technology available to all the farmers and for the successful adoption? This should be the biggest mandate for any government agency, not the technology development. Whatever the technology available is more or less sufficient. Once we adoption is stabilized, we can meet easily the water scarcity challenges. Number one. Number 2 is exactly re-researching the water management research. This means normally people will say yield gap is from what the farmers are getting, what the research station getting. But we have to partition the yield gap analysis into yield gap 1, where the traditional level of adoption and the improved level of farmers practice. What will be the yield gap? In our research, it is about 20% yield gap. Then second yield gap is from the progressive farmer to the research station level. This is about 15% gap. So almost 30% gap is there. But when you partition the yield gap, it is easy to put the appropriate technology at each yield gap level. That is very, very important. So to strengthen that one, we have to inbuild the capacity building program. So all the capacity building programs related to each technology should be strengthened, all at the region level, at the village level, at the cluster level. That's the second one. Third one is giving importance or emphasizing on the special programs like micro-irrigation. Micro-irrigation is not the one-time solution. not the old solution also. It helps, okay? It saves water, but may not conserve the water at the macro level, okay? So, but in India, there is much scope for expanding the micro coverage. The potential is expected to be 45 to 69 million hectares irrigation, micro potential. But so far up to 2020, the area coverage is only about 13 million hectares, about 18%. So there is a more scope for expanding the micro irrigation areas that are more vulnerable, particularly groundwater irrigated areas. There are two areas where micro irrigation is expanded. One is giving a good implementing programs, governance. One model that works in India is the Gujarat Green Revolution Company, GGRC model. It works very well because within a week, farmers get all the micro irrigation installed the form, third party inspection, everything. It works very well. We did it, we also studied. Second one is why the micro irrigation not spread in most part of the thing is subsidy program. Central state government are giving subsidies, but because of the timely not managing the timely implementation of the subsidy programs, most of the farmers are lacking behind in implementing these subsidy oriented MI systems. So one possible area where the policy makers can think is, why can't we inbuild the subsidy in the production itself, supplier itself, manufacturing itself, so that the micro irrigation system can be available at the market at any price. Farmer can buy it at a lower price compared to what they are getting at the subsidy price. That may be one areas that the policy makers can think about expanding the micro irrigation. Fourth area may be developing technology clusters. So far, we are talking about technology as an isolated piece. Every farmer, one farmer use SRI, one micro irrigation, everything. But that is one of the reasons why the technology uptake is failed, because the variability in the soil type, farmer attitude and access, etc. If you adopt a cluster of a technology cluster, take a village or a cluster of 4 or 5 villages, put one technology, capacity building program, everything together, that may success. Here the public participatory mode, PPP mode, will be useful to developing a very good business models. Even wastewater recycling, even combined transplanting at the village level, harvesting, even spraying. So this kind of a business model will very well develop using a digital agriculture. Once this is successful, then all the climate smart technology will be easily accepted by the farmers. That's one. Then fifth is re-engineering the modernization framework itself. We are so far talking about irrigation project modernization. Most of the programs are knowing only hardware part, improving, okay, rehabilitation of the hardware part. But in the recent years, it's not more, it is more than the hardware rehabilitation, even modernization, where we are inbuilding efficiency parameters also. So in the future programs, both hardware and software, engineering and agriculture, capacity building, everything digital, everything is inbuilt. One such program is now being introduced by the Asian Development Bank in association with the Central Water Commission, Ministry of Water Resources. It's called SIMP, Support for Irrigation Modernization Program, where it takes from benchmark to asset management level. It covers everything, all aspects. So this may be going to be a good model for future expansion of the modernization program in India. Then the sixth area is, which I am not telling, is a rainfed area. Because climate change is affecting more on rainfed areas. Okay, effect is more on rainfed areas because India has more than 60% areas on rainfed. Because the high variability in the rainfall, most of the rainfed crops are failed. Several areas farmers are committing suicides. So one best way how to counteract the climate change on rainfed area is, one is providing some kind of a supplemental irrigation, 2 to 3 supplemental irrigation. A business model can be used for supplemental irrigation, providing supplemental irrigation for portable sprinkler, etc. This I have seen in several locations. Second one is strengthening the watershed programs. Watershed programs are very tricky because if you mushrooming up the watershed program also hamper the run up to the water bodies. So watershed programs should be put in such a way that it will have a recharge benefit to the groundwater. So wherever the groundwater intensity is high, watershed program will do a better job. So that recharging is good and providing supplemental irrigation to the groundwater is also possible. So this kind of things can be easily seen as a viable options for future policies. So these are the broad 6 areas which the policy makers, the government can think about strengthening the upscaling of the technologies. Once the technology upscaling is done, at least 20%, currently 10%, 20% level technology upscaling is done, then our stability in the food production in spite of the climate change impact is possible and assured. So this is my brief views. Thank you very much.
Thank you, Dr. Palani Swami, for sharing your views and remarks. Now I'll request Mr. Anshuman to share his presentation with the participants. Mr. Anshuman.
Thank you. Thank you. At the outset, let me thank ICID and as well Dr. Yella Reddy for giving this opportunity. I'll just share my presentation. Can you see it? Is the presentation visible?
Yeah, we can see it.
We can see it.
Okay, great. Thank you. I think I think a lot of what I wanted to say is already said by Dr. Palani Swami, but I do want to give some examples of, substantiating the same. Water use efficiency in irrigation is something that is very important to look into. There have been several challenges across the sector since years: low irrigation use efficiency, low irrigation water use efficiency, lack of use of efficient technology, especially MIA system, which have been there since quite some time, but we have not been able to upscale it. I mean, what Dr. Reddy also mentioned, we had a potential of around 70 million hectares, but till 2018 we just had reached around 9 or something, like that million hectares of MI system application. Then there are other challenges of gap between irrigation potential created versus utilized, etc. But to talk to it, the potential impact of the climate change. Now, what is required to be done is in every sector irrespective is to improve efficiency, reduce wastage where possible. And in agriculture, this is not different. If you talk about the agriculture, water efficiency and irrigation, what's important is that we are able to look into, how, water efficiency is improved, because the sustainable irrigation is important for food and water security. And technological solutions are really very important for really upscaling them and in different hydrogeological and socioeconomic setup to basically achieve a critical mass impact. And that's very important to intervene. We have, as Dr. Palani Swami said as well, we have been having technological solutions in some time. But how do we look into upscaling them is something that is very important. We also pointed a very important perspective that unless it reaches the farmers, unless we are able to look into addressing the challenges for farmers for adopting such technologies, the real impact at the wide scale will not be achieved. And in that sense, it requires a mix of intervention, water use efficiency, including efficient and affordable technologies, effective policies and sustainable finance mechanism, as well as inclusive water management, which involves the local stakeholders and farmers by making them aware of these technologies and building their capacities to how to address the bottlenecks and make it conducive for them to adopt the technologies. So a mixed bag of interventions is something that will actually improve the situation. Now, I want to give you 2 examples of something that we have done in the context. One is Optiflow, and the other is a project basically taken up by the Government of India under direct benefit transfer of electricity, a project called Pani Bachao Paisa Kamao, save water and earn money. So the first one I want to talk about is Optiflow, which essentially is about looking into how we are working on a device which promises to improve the water and energy efficiency by controlling the water flow. Basically, the pressure independent flow, which requires the, water flow modulating input pressure, and it brings the variation between less than 2%. Currently, the systems have flow variation of, around 8 to 15%. And of course, because of that variation, you have a larger, water and therefore energy consumption as well. So this device, which we actually had developed, along with our partners in UK and India, we have actually put it over the sprinkler system. So what we did was we tested the we tested the device over the 2 sites set up, one control and one test site, wherein we put this device along with the sprinkler system. and try to understand how it performs. So what we observed was that, it did have, pressure constancy achieved at, irrespective of the input pressure variation. It reduced the pressure and achieved the constant pressure, which was required, which was basically promised by this device. And we tested this over several devices that we had developed, and we found the constancy. What we also observed was for the sprinkler systems, in the control versus test site, we observed a water, saving of around 1,000 liter, per hectare. And also in case of drip irrigation system, there was a fair bit of, water saving as well in terms of using this prototype, around 1,600 liters per hectare. Now of course, this was first set of testing, and based on this, we also further modified the prototype and did many laboratory testing for its validity and ruggedness, etc., including resistance to high pressure, durability test, and so on and so forth. And this is how it looks like, this device, which is applied over. And in fact, this can be applied to any kind of pipeline of different sizes as well. And therefore, using this in agri-irrigation systems would make a significant change. Now, what we did with the final testing was we took it up to a fair bit of field size, and irrespective of the inlet pressure, as I said earlier, we found that the pressure was maintained much below and at much lesser pressure range. And this, of course, led to a water saving of around 11% to the level of around 6,000 liters, 6,600 liters per hectare. And as well as saving of energy. In fact, in case of control site, which was without the device, without the setup, it was having a much higher flow rate, power consumption. So overall, just to summarize this particular part, the device helped achieve water energy saving of around, as I said earlier, 11% in case of water and some around 4% in case of energy. And this is very conducive and has flexible design to take up with a uniform application rate at different hydrogeological setup, especially in the undulating areas and hilly terrain. I want to quickly shift to the other one that I talked about, which is Pani Bachao Paisa Kamo. This is basically done and is in fact is still being implemented in Punjab by assistance from World Bank, and we had the partners of World Bank, ESMP, Punjab Agriculture University, and so on and so forth. The particular project, what we did was we actually went into the ground and in different locations, in different feeders and locations, and worked with the farmers to demonstrate to them how these technologies are efficient, what difference would they make. We actually created a demo farm, and in that demo farm we demonstrated all these technologies and their benefits. Now we left it up to the farmers for them to decide and choose what they want to choose. So, and it was a very innovative sort of method in which, you are not forcing a system on the farmers, but rather demonstrating to them, the kind of benefits, and also hearing from them what are the kind of bottlenecks that they face, in adopting such kind of technologies, and working with the government, trying and facilitate to bridge that gap of, bottlenecks which existed. Doing so, we held into, we used all the kinds of possible mechanism of communication and outreach, interacting with the farmers on field, building their capacities, basically clearing their doubts and facilitating that, bottlenecks to be reduced or, even taken off. And in the process, we also monitored what is the delta change between, their common usual practice and these practice. So what we found was, and there were, of course, we looked into various kinds of, measures of water productivity and water saving. So we presented to them all these that you can see over here, a bouquet of interventions, including MIA system, underground pipeline, laser leveling, mulching, foreign irrigated, planting system, short duration varieties, direct sowing of rice, etc., etc. And amongst these, the farmer chose few, not all. And then what we found was in the season, for example, this is the output of the Kharif season. We found that in one of the locations with the implementation of some of those selected interventions, the range of water saving varied by and large between around 21 to 32%. It's quite significant, and this was basically something that the farmers applied themselves with our facilitation of the bouquet of intervention that we presented to them. And if you look into the these parameters of agriculture and water productivity, irrigation water productivity, water use efficiency, and total water productivity, which includes besides irrigation the rainfall as well. all of them were, quite, noticeable and basically better than the, control farm, the demo farm, in which we basically introduced all these technologies along with the farmers on ground. And in the other feeders as well. So these are just examples. There are other feeders as well in which we worked, and all of those showed, fair bit of, water saving. And so was the case of Rabi season as well. Again, if you look into the various kinds of interventions that we, put in demo and the control farm, the demo farm where the interventions were, applied along with the farmers had, again, over here, some around 10% of, water saving. And again, a better agricultural irrigation water productivity, total water productivity, and total water use efficiency by and large. And so was the case in other feeders in the Rabi season as well. Now, the potential impact was that these interventions, as you can see, in different, test sites and farmers, that we worked with, in both the seasons, there was a fair bit of, water saving achieved in both the seasons. And also not only, water saving, but also energy saving that was achieved. So this project actually was something which actually emphasizes what I was mentioning earlier, and as well Dr. Palani Swami was mentioning, that the technologies have been there for some time, but unless you, look into how can you facilitate to, convince the farmers to adopt them on ground, and there will be many challenges in the process of, prioritizing one technology or process over the other, the real impact at a wider scale will not be really achieved. In this particular case, we saw that there was a fair bit of, what is potential savings in feeders, around 26 to 47%. This could be further improved with other interventions taken together. And of course, with facilitation of the process and building the capacities. So I want to give some key messages, that technological upscaling needs innovative mechanisms to remove the barriers at the last mile of connectivity and provide evidence-based solutions on ground with demonstration and capacity building on field support systems, as well as facilitating the stakeholders for prioritized intervention. It cannot be one size fits all solution. Of course, there are various technologies and innovative technologies already on there, and they are future, as far as, efficient irrigation is concerned. What is important is that enhancing irrigation water use efficiency, we have timely adoption of innovative approaches and technologies through conducive policies that can overcome the persistent barriers which have been there. And this is something that we worked out on ground. There have been technologies, but the farmers, for example, had some or the other problem of not being able to adopt them. Either the application is a challenge, or the troubleshooting is a challenge, technical know-how, lack of technical know-how is a challenge, or even the price is a barrier. So all of that has to be looked into and customized over a period of time so that they are able to bring about wide-scale transformative impact through a multi-stakeholder engagement involving the farmers, of course, on ground, but also the local agencies, the government agencies, as well as corporates who can provide a better market mechanism in particularly in context of the farmers. So I would want to stop over here. I think I just had around 10 to 12 minutes. I will be happy to take more questions if there's any. Thank you.
Thank you, Dr. Anshuman, for your very good presentation. And with this, we complete all the presentations. Now we can take a few questions only, because now it's almost 2 hours since we started. So we can take few questions. I'll read questions, and then any of the panelists can give the answer, whoever feels that they can provide that answer. So I'll start from the latest question. It is from Mr. Chris Perry, which is at the time of presentation of Mr. Anshuman. Are these water savings in terms of consumption, ET, or water applied to the field? One slide mentioned both.
So you might have noticed we have taken both the things into account. It's actually, the water applied as well as, the total, which is inclusive of rain. So the factors are both, and we have actually taken both into account. So the total water saving, actually, in one case where we have measured this is basically by the measurement of water consumed, which is applied, not exactly the ET, which is of course something that as well is a water loss from the system. But what we have done is a water measurement, which is what is applied on field. So we put meters on ground and looked into what was consumed in both the control and demo farms.
Okay, thank you, Suman. Another question is from Mr. Safkat. He is asking that do we have results on CU and distribution uniformity DU for design, control, and tested improved prototype sprinkler irrigation system?
Yes, we very much did that, and they were very much in the range which was expected. It did not affect their CU and distribution uniformity by application of the Optiflow, which I mentioned about. It did not affect them, so it was conforming to both of these factors. We did that as well.
There is another one comment from Dr. Vijay Lapsaitwar on Dr. Palani Swami presentation. He is saying that capacity development is very important part, and then capacity development is generally done for the training is done by sprayable people for sprayable trainees in their sprayable time. So that is just a comment, which is very important, but we are giving least importance to the capacity development part. So there is one comment.
Yeah, actually, capacity building is an integral part of any technology development and scaling. Actually, we did an experiment with 1,000 farmers on drip irrigation capacity building some time back. So 90% of the farmers were doing the drip irrigation, but not knowing the exact maintenance, vertigation, pressure maintenance, etc. So what we did was we put a cluster approach. Each village we put in some farmers' field itself, direct hand-on training. So the hand-on training, particularly on specific number of days, worked very well. Other days, in some other technologies, some farmers having SRI and AWD, etc. We went to the farmers' field itself, put a hand-on training. So the hand-on training helped a lot for the farmers. From them, other farmers started learning how to use it. That worked very well. Thank you.
Thank you, Dr. Palani Swami. Another question is from Mr. Safar to Dr. Marco. He's saying very good. In our case, Uzbekistan, we have a number of agri-technical, tillage, etc., environmental, soil, salinity, fertility, etc., and other factors that influence on crop energy reflection response that cannot be captured by camera of drones or satellites. I am very much interested on Irriframe app. This is a very useful tool for farmers. Good for further research. So
yes.
If you want to say something, you can share some details of Irriframe so
yes.
that people can look into it and how to get it.
Yes, of course. I'm very happy that this kind of approach has been facing some interest because I believe, as you have seen, and the results have been showing this, that irrigation scheduling is one of the most important aspects to be taken into account in order to save water and to efficiently manage irrigation. Of course, there is a lot to do. Actually, before these pandemics, and Professor Dr. Raghav maybe will remember this, but you also will remember this, I was planning to introduce the person which Dr. Raghav knows very well. His name is Paolo Mannini from Italy. And I was actually planning to extend or to give a broader diffusion, if possible, of course, depending on the quality and amount of information available in other countries. But I believe this approach can be very, very interesting, very useful for saving water and especially for saving money for the farmer as well, because what has been witnessed in the northern part of Italy, the farmers, most of them are really enthusiastic about this because they discovered, they witnessed that they were using much more water than it was really needed. So they were saving energy, because one of the major aspects that has been coming out during this webinar is the aspect of energy and cost of energy. So I believe that, of course, when this will be possible, it was my intention to involve Dr. Paolo Mannini, who is the person who developed along with other people from Consortium Emiliano Romagnolo, this expert system. I believe this is something that as ICID community, we can also take into account, because I believe it can be very useful. Of course, provided we have good quality and good information regarding water table, meteorological data, soil texture, and so on. But of course, it is something we can work on, I believe.
Yeah, the associated question from Dr. P.S. Rao is that can you indicate the cost per hectare to use irriframe here in India?
In India? Well,
Or
actually,
cost per hectare.
Well, no, look, it works like this. Farmers, here in Italy, the system is organized in such a way that farmers who receive irrigation service, irrigation water delivery from irrigation consortium or consortia, they pay, sometimes they pay on a basis provided by water consumption, like in Southern Italy, especially now, is becoming the rule in Southern Italy. Farmers will pay, as I shown in my slide, they have a credit card they can put inside the delivery systems. They will have a certain amount of water. But just by participating to this system of irrigation delivery, they are provided with this service. I mean, it's the Irrigation Consortium and the National Association of Irrigation Consortia who provides this kind of advice. So if you are a farmer who is part of an irrigation consortium, then you are provided with this expert system. Of course, why? Because of course, for the consortium, for the irrigation consortium, it is much easier to know that you are dealing with farmers who are inside your irrigation network. That's why farmers are involved. They are, how can I say, they are motivated to be part, to enter the irrigation consortium, because you have better services, you have higher forms of organization, you can save water, and you can increase your income. So, I mean, there is not actually a cost you have to pay. You have to be part of this, you have to adhere to this irrigation consortium. And of course, according to your farm, according to the surface, to the extension of your, to the hectares of your farm, you will pay an annual fee. In some cases, you pay, like, for instance, in the northern part of Italy, central part of Italy, you just pay according to the extension of your farm. What is becoming more and more common, of course, this is a policy adopted by local politicians or stakeholders or decision makers. In the southern part of Italy, it is becoming more and more frequent to pay, for farmers, to pay on the basis of what you have been consuming as water. There is, of course, a flat tax rate, how can I say, a flat fee you have to pay just because you are part of this irrigation consortium, because the system has to provide drainage for your area, drainage for your farm. So you have to pay a flat quote of the fee. But then all that is provided in terms of irrigation and water, you can pay in. Recently, it has been adopted, this new approach. You can pay according to what you have been consuming for water. For instance, they will give you, like this card, they can give you, if you have tomato, they will give you, like, I'm saying a figure like 4,000 cubic meters per season, per irrigation season. If the season should be running particularly dry and you need more water, you can ask for more water, provided that the water is there in the reservoir, because in southern Italy, most of the irrigation comes from reservoir. In the northern part of Italy, irrigation comes from river flow coming from the Alps. Of course, they also have reservoir, but most of it it's depending on surface water flow. So if the water is there and you need to have more water because maybe you have been running through a particularly dry season, then you can have some more water, but you will not pay the same amount of money. You will pay an extra amount of money because that increase in water needs a higher cost. So, I mean, if you adhere to the irriframe system, is provided to all the farmers who are part of this system of irrigation consortium. So there is What you pay by being a part of the irrigation consortium includes the e-frame service.
Thank you, Dr. Marco.
Thank you.
The two persons have raised their hand, so we'll give them also chance to speak. So we'll take one of them, Dr. Dharamveer Thareja. He has raised his hand. We'll give him, then he can speak for 1 or 2 minutes, and then the panelists can respond to his comments or question. So, Dr. Thareja, you can unmute yourself, and then you can speak.
Thank you very much. It has been really very educative and kind of a good variation of developed situation and the way we are catching up. My question is that I have been to some fields where groundwater is saline. The canal water or the irrigation coming through canals is kind of 40 days, 35 to 45 days in period duration. And uncertainty of irrigation is significant, and the productivity loss is really because of these factors. Have we got some model which can help them to bring in more of micro irrigation, whatever we have been projecting? Thank you.
Dr. Reddy, you can decide who is going to answer his question.
This is, yeah, just let me. The canal water is supplied only 45 days, okay? And then it depends on how you plan, schedule based on the what type of crop, what is the crop duration, what is the water requirement for it, okay? You have to consider those factors. And groundwater is saline. To what extent the saline water can be used, okay, that is again to be analyzed and modeled also. Now you have to have the options. We also supply canal water for micro irrigation, provided we have the enough storage in the field. Okay, we will have to have a structure to store water. Canal water comes that you have to store in the fields, again irrigate during the deficit time. So we can have the combination of things based on the local situation. So that is what Dr. Dharmaja has said, Taneja has said. So these things have to be taken care. I think, okay, I think Palani Swami can also add something on this. Palani Swami, you have to unmute.
It is a typical case of a conjunctive water use, okay? Both canal and surface water. There are several models already developed in Haryana and Punjab cases that can be explored. Thank you.
But irrigation is kind of 25 minutes per acre. That's a kind of a time frame of the canal, and that hardly meets the requirement.
Yeah, but there is a, I think there is a interaction between the canal water intrusion and the groundwater salinity part. So that should be carefully studied, and then recommendation can be given. I have no, as such, I have no
Thank
idea.
you. Thank you.
Thank you, Dr.
Just to,
Reddy and Dr. Palani Swami. Yeah,
I just wanted to sort of indirectly complement the answer. I mean, the precise reason for this Pani Bachao Paisa Kamao thing in Punjab was to basically arrest the groundwater usage. So what you are ultimately trying to do is, of course, you cannot totally stop it, but then, the idea behind is to see that, by efficient practices, you are actually consuming less water and definitely less groundwater abstraction and reducing the wastages. So of course, it's not related to salinity in particular, but then, the one that I gave as an example had an objective of basically reducing the groundwater consumption and dependency, by and large the way it is.
Okay.
I think our president, Dr. Raghav, he has a lot of expert in the SaltMed software or that modeling they have done. He can also give his opinion, I think. Dr. Raghav is there, I think.
Yes, I am.
Yeah, please.
Well, the saline water really management in terms of groundwater and the use for irrigation is well documented in several papers published by ICID, Irrigation and Drainage, in a special issue appeared May 2020. And it is available actually on the website of ICID, and also the model, SaltMed model for managing saline water in terms of the predicted yield for certain salinity, what will be the best irrigation that actually suits, irrigation system that's suitable for using saline water. And especially what we found in our work, the subsurface drip irrigation, 10 to 12 centimeter below the surface, did work well when using saline water. And also we found that sometimes when you have the two sources of water, saline and the fresh, we use that in alternating way. So the time that, for example, you have fresh water, you could use it and then it will leach the salt, and then you use saline water, and next time if you use fresh water would actually leach the salt. The other thing, also rainfall events. You could make good use of the rainfall forecast. If you forecast rainfall to happen, then you don't irrigate with saline water, and then after the rain, during the dry period, you could use the saline water, and also the rain will have impact on leaching the salt. So there are certain type of management also mentioned in the documents of the model. There are about 25 papers actually documented there for the use of saline water and use SaltMed model, which is freely available at the ICID website.
Very nice. Thank you, Raghav. Thank you very much. Varma garu, anything more questions there?
Another one or two questions, because they are there, and then we will not be able to answer all. We'll share with the panelists, then they can answer them individually also. So one question, Dr. Reddy, it's for you. Yeah. What is the opinion? What is your opinion about present projects which are executed in India, like Ramthal project in Karnataka or pipe distribution network in Madhya Pradesh? Will these type of projects are useful for increase water use efficiency and betterment of farmers?
Yeah, this is a very important thing. The Ramthal project is one project taken up in large scale, micro-irrigation in the canal areas of Karnataka. I am into the designs of that, but technically everything is very much there possible, and some farmers are also getting benefited. But it should become more comprehensive. Okay, not only water efficiency, but the produce, the processing, value addition, marketing, there should be linked. Okay, there are some areas for lot improvement in that. So that's what our opinion we have presented to the government also. Ramthal is one big project. That's a good beginning. We need to further strengthen it for more adaptation. Similarly, the MP, the pipeline network for carrying water, that is a very good initiative again taken to arrest a lot of losses. Today, MP is, I have seen one in the chat box also, this from Martin Burton has mentioned that one. MP is doing really well. Okay, strengthening management has to be given more attention, what he says, in addressing climate change adaptation. Okay, that is necessary. In Madhya Pradesh, the Water Resource Department increased the utilized irrigation area from 35% to 85% between last 6-7 years. The irrigated area increased from 0.8 million hectares to 2.8 million hectares through improved main system management combined with a modern MIS database. So that's what they are carrying water through pipeline to the unreached places. And now we should ensure that the water reaches the downstream people also at very low cost, what he mentions. So those things are very much appreciated, Varmaji. We need to take it forward. Thank you.
Thank you, Dr. Reddy. Mr. Dorji, he has raised his hand. We'll give him time because he is implementing ADB project in India. So we'll give him the time, rights to speak. So we are unmuting yourself. So you can unmute and then speak.
Thank you, sir. Thanks a lot for giving me this slot, sir. Sir, as mentioned, Mr. Swami, because this is a new initiative we have already taken regarding SIMP. A lot of state governments have shown their interest in this, and first phase we have completed. Second phase we are on the way towards second phase. Now coming to 2-3 points, Mr. Reddy has presented during his presentation exactly water use efficiency. What for we are going water use efficiency? Water use efficiency. This adaptation will come only if farmer will get income from that. Yes. Our main issue is our farmers are very small land holding farmers. They got very small land, and the adaptation of these technology, what we are saying, we are speaking best technology over the world. It is very difficult unless he will not understand I am going to get 2 rupees or 3 rupees more from this adaptation of this technology. We got in India, we are saying major water is being used by irrigation sector. If we will increase the water use efficiency and the present available within the, we can cover much more, command more area for irrigation. So thing is how we reach to the farmers. He has mentioned Valmi and other institutions carried out the baseline study. Okay, fine, wonderful. We are doing baseline study. What happened to that study? What for that study? That is not to present a paper or something. We have to go to the farmer or the engineers again back to see this is the performance of your project and why it is like this. Because in that study, we are giving some observation. These are the points due to that your efficiency is low. We have to improve those points. If we'll improve those points, definitely the benefit is going to get by farmers. So this is here why my request is, because we have to work with farmer, we have to educate them, we have to translate all these technology and the what we are thinking to farmers so that he can use it, or we can see what he proposed, because farmer got much more. Because I belong to an area where I grow apple. We know how we are using, because government got different policy. We are adopting our own traditional methods. So we have to have with farmer, we have to understand them, and we have to use their know-how with them, and that will give us definitely benefit of the all efficiency and other thing. Thank you, sir. That much I wanted. Thank you, sir.
So it is wonderful listening to you. Really true. Okay, this is a way the farmer gets interested unless he gets the benefit and the profit. So this is not only productivity. Okay, profitability is important. That's where I always insist on that. Whenever a policy comes, how the farmer gets more income is important. That's what I said in the even Ramtal project, when this project is implemented. So it's not only production, how that can be converted into the profit to the farmers. That is, I totally agree with you. And always wherever we work, we take our findings to the government for adaptation and ensure that it really benefits the farmer. This is good feedback. You gave good observation. I totally agree with you. This should be the responsibility of all the professionals, okay, who are involved in this area. They should take up like this. I thank you very much. Thank you, Varma Garu.
Thank you, Dr. Reddy. Thank you all the panelists. I'll request our president, Dr. Raghav, to say a few words before we finally close it. Dr. Raghav.
Thank you very much, Mr. Harish. I would like to thank all the panel members and the speakers for such a valuable, really, information we benefited all of us today from. And I would like just to say a few words about the main issue, really, which is now to double the food of the world by 2050 to feed 9 billion people. And that would require really either increasing the water supply or to use the current resources more efficiently. And that's really the issue that we were really addressing today. How can, with the limited water resources, feed the world in 2050 and doubling even that food production. So you really, in the presentation, we have been talking about how can we increase the water supplies. And also we talked about how we can efficiently use water as a resource, and also how can use the smart technology to improve the water use efficiency and water productivity. So we have been really addressing the two issues, how to improve water use efficiency and water productivity using the hardware and the software. And actually the software now coming into more of interest to a lot of people. And it seems to be really, by the results we have seen today, very efficient to use, and also very important to conduct capacity buildings and training for people to use that the software as well as the new hardware technologies. So these are actually two good directions. Now the smart technology as a hardware and software to improve the water use efficiency and water productivity. And we have seen today really a good deal of the smart technology and a new type of management as well, and even new irrigation systems coming into the field of irrigation. And I would like just to make one more note, because Chris Perry referred to, is the water use efficiency. The water use efficiency unit, it has no unit. It's output divided by input, both of the same units. And for that reason, it is dimensionless. And Chris actually was in charge of a position paper of ICID. And he made a good collection of the knowledge by other colleagues on that issue of water use efficiency, not to be confused with water productivity. Water productivity has units, is how actually much product that come from unit volume of water. And usually water productivity has units, commonly gram or kilogram per cubic meter of water. But also on the other side, there is some recent work by also Chris and President Honorary Bart Schulz and some other members of ICID on water accounting system related to the water use efficiency. And in that actually, he also published with members of ICID papers on that water accounting. For example, that water use efficiency, it might reduce the recharge. For example, you can use the water more efficient, but also you might have to pay attention. There is another element of the water accounting system, like ground water recharge might receive less water. So the efficiency might have a negative impact on the groundwater recharge. So when we talk about water use efficiency, we might have to take it within the context of the water accounting system, and Chris and President Honorary Bart Schulz and members of ICID, they are now referring to the fact that we should take on board the water accounting system when we really deal with water use efficiency and water productivity. So this is just my comment, because I know Chris was really with us today, and of course he already referred to the fact that we shouldn't confuse the water use efficiency and water productivity. But at the end, really, it was a very fruitful day, a very productive day, and we really did benefit from a great deal of new knowledge coming in. And I would like to thank you once again, and hope to see you physically at the next ICID meeting, hopefully November in Marrakesh. Thank you very much, and have a good day.
Thank you, President Raghav, for sharing your views and clarifying the position on water use efficiency and water productivity. And this is the ICID position which we are adopting, and sharing knowledge, information about salt bed with the participants. So now people, the attendees can use that model wherever they need it. I thank Dr. Reddy, Dr. Palani Swami, Dr. Marco, and Engineer Anshuman for sharing very valuable views and presentation on the topic. And I thank all the attendees who have joined with us and participated in the discussion. It was a very fruitful and lively discussion through, although because of time constraint, we could not give chance to all the persons who have raised the hand, or we cannot answer all the questions because of time constraint, but some of the questions have already been answered by the respective panelists directly with the in writing in the question answer session. And then we'll share these questions as well as chat with all the panelists, and then they can directly refer to the questionnaire and then respond to their queries. Thank you very much. Thank you, everybody. Bye.
Thank you. Thank you.
Good morning and good
Bye-bye.
afternoon.
Bye-bye. Bye. See you next time.
Please stay
Goodbye.
safe, all of you.
Yes.
Yeah.
Bye. Thank you. Bye.